Hey everybody, this is Gregory from Dapp University. So today I'm going to be showing you how to deploy smart contracts with the Web3.js library. And the Web3.js library is, the main JavaScript library for interacting with the Ethereum blockchain. And, this video is a video in a series of videos that I'm putting out about how to use Web3. And today, I'm going to show you a video that kind of builds upon the previous video in the series where I showed you how to create, transactions on the Ethereum blockchain with Web3. So check out that video if you haven't already. And you can also check out my website at dappuniversity.com, where I'm going to post the code examples for this. And also be sure to subscribe to the channel to see the next video in this playlist when it comes out. All right, so whenever we are deploying a smart contract, to the Ethereum blockchain, we are creating a transaction. And that's important to know, right? So whenever we create a transaction on the Ethereum blockchain, we're writing data to the blockchain, we have to pay a gas cost, and it creates a transaction, it creates a record on the blockchain that, is there forever, right? It's a transaction that's written to the blockchain. Whenever we create a smart contract, on the blockchain, we deploy it, we write this transaction, and the contract is now there forever. So today I'm going to show you how to do that with Web3.js library. And there are a few ways to do this. You can deploy a smart contract with some nice Web3 utilities. If you have access to a Geth node, where you have, personal account information and things like that. You can use, the personal object, the personal library inside of Web3 to deploy a smart contract. But I'm actually going to do this like the most manual kind of way to show you how these transactions actually work, right? I'm actually going to create a raw transaction that deploys the smart contract data, and it's going to sign the transaction with a private key, and we're going to broadcast that transaction to the network and deploy the smart contract. So this is going to be a very similar example to the last video where I showed you how to create a raw transaction with Ethereum. So check out that previous video if you haven't already. This is going to build pretty heavily upon that implementation. So I've got some boilerplate code set up here. You'll of course need all these dependencies, which you've used in every other video in this series so far. You'll need this Ethereum.js TX library. You can just install this with Node Package Manager. You'll need the Web3 library, which can also be installed with Node Package Manager. And you'll need an Infura link. This is going to be an RPC connection to a remote node hosted by Infura on the Ropsten test network. We're going to be using the Ropsten test network today. And you'll need at least one account. I'm going to go ahead and kill this second account because we don't need that. All right, so you'll need the account's address, and you'll need its private key so that we can sign the transaction. I've hidden my private key off screen here with an environmental variable. I showed you how to do this in the last video. You don't have to do this. It's just safer, and I don't want to show you my private key, so that's why I've done this here. And we want to convert this private key to a buffer that can be used by this Ethereum.js transaction library. All right, so in the last video, if you remember, basically what we did was we created a we created a transaction object, and then we basically signed the transaction, and then we broadcast the transaction. All right. And I'm just going to paste in some of this code from the last example. If you want a more in-depth explanation of what's going on here, be sure to check out the previous video. So yeah, this is how we broadcast the transaction. This is how we sign the transaction. And this is how we're going to basically create the transaction here. We'll say const tx object. And this is going to take some values. nonce, the gas limit, gas price, and the data. Okay, and we get the nonce value by getting the transaction count by getting the actual transaction count from the account that's going to broadcast the transaction. And we'll wrap all this inside this callback function like this. Again, if this is too fast and over your head, check out the previous video where I explain kind of everything I'm doing here in depth. I don't want to have to reiterate this in every single video, just in case someone's already seen the other video. I don't want to bore them. So just another high-level overview is we're creating this transaction object, that's going to actually get, broadcast to the network. We're assigning it with this this library here, and then we are actually broadcasting the transaction to the network with web3.eth.send signed transaction. It's going to accept this raw transaction that we created, and we'll get the data here. So the values that we're sending for this transaction are going to be, web3.utils.2 hex. Remember, all of the values inside this raw transaction object need to be in hexadecimal, so we need to convert the transaction count to hexadecimal. We're getting that here from the value that we're injecting with this callback function when we're getting the transaction count of account 1. Remember, the nonce is just the number of transactions that the account has already written. To prevent the double spend problem, we need that whenever we're creating a transaction object. And the gas limit is going to be the maximum amount of gas that we have to spend in order to create this transaction. So let's say web3.utils.2 hex, and we'll use a pretty high transaction. Let's do 1 million units. And we'll say the gas price is going to be web3.utils 2 hex. We'll say web3.utils two-way. We'll pass in 10 Gwei. All right, so I should mention that deploying a contract is going to send some data to the Ethereum blockchain, which is going to cost a lot more gas than just like sending ether back and forth. So we must raise this amount. Let's say raise this. This is a lot more than 21,000 units of gas, I believe, is what we used to create an Ethereum transaction to send ether back and forth. Now, why am I doing this? So I'm doing this to show you that when you deploy a contract to the Ethereum blockchain, you're creating a transaction, and you can do this like you can assemble all these pieces yourself like this to see how a transaction works. So when we are creating this transaction object, like almost forget about all the individual pieces of what's going on down here. Just notice that this is what sends the transaction to the network. This is what signs the transaction to tell us that, hey, it's this account that's trying to do this. And then this is the actual data that gets sent, right? So don't worry about all the details necessarily if you don't understand it. This is just the data. This is just telling us who sent it with a signature or kind of like a password. And then this is the actual sending of the data. So the reason I'm showing you this is to show you that you can create a smart contract by creating a transaction like this. And essentially what you do is you send the data, the actual byte code of the smart contract that's going to get executed on the Ethereum virtual machine with this data field here. And notice there's no to field, like there's no to. Like normally if you're going to send ether, this would be an address, right? We don't need that because we're sending this we're broadcasting this transaction to the entire network. There's no specific recipient. And that's what happens here whenever we deploy a smart contract. We are broadcasting a transaction to the entire network and saying, hey, here's the data that we are trying to broadcast. This data is going to be basically like code of the smart contract. All right, so in order to do that, we need to fill in this data. For now, we'll just say data. And we'll actually need to get the smart contract data. We'll say const data. We'll pass it a string. Now, how do we get this data? How do we actually get data for a smart contract that we want to broadcast to the network? Well, we need a couple of things. We need to basically compile this smart contract down into bytecode, and we need to get some data that this is going to understand, that the blockchain expects. And I mean, before that, we also need a smart contract. Like, we need some code that is going to get deployed to the Ethereum blockchain. And I'll show you kind of all that. So let's open up Remix. This is remix.ethereum.org. This is a browser-based IDE put out by the Ethereum Ethereum, and basically allows you to keep a list of files that you can save, smart contracts that you can compile, run, and deploy. So what I've got here is a smart contract that I built in some of my previous tutorials. I have a pretty long series called Code Your Own Cryptocurrency on Ethereum, where I show you how to build an ERC20 token. So you can check that out if you're interested. I also show you how to build like an ICO website and a crowd sale, things like that. So check out that video if you're interested. But this is, the token contract that we actually build in that video. This is an ERC20 compliant smart contract. So you can, copy this code if you'd like, or you can really get kind of any ERC20 token code if you'd like to, and deploy this to the blockchain. I should probably put a link to this down in the description below, or if you're watching this video on my website, I'll put, this code below the video. So you're going to need the smart contract inside Remix, which I've pasted here. And what we want to do is actually start to compile this thing, and we'll click on the Details tab. And this is going to give us some information that we can work with. We can see a lot of different things when we've compiled this. We can see the bytecode here, and the ABI, and some instructions that say, hey, if you want to deploy this contract with Web3, here's how you do it. Now, remember I said Web3 kind of gives you some ways to do this if you have access to, the personal object inside of Geth, the personal library inside of Geth, or if you're doing this on the web and you actually have the ability to use something like MetaMask to sign transactions, right? You can do that. But if you don't, and you want to do this without trusting a node, we're going to do it our way, which is to build a transaction manually. And so I'm going to, this basically tells us the data that we need to send inside that transaction here. So what this is just the compiled down bytecode converted into the hexadecimal value that we need. So let's copy this and go back to our project. Basically going to just paste this in here. It's going to take a second because this string's really long. I'm going to copy this string out and delete all this junk. And I'm going to paste the data inside this long string here. All right. So save that. I'm going to minimize the window here. And now I'm going to actually, create this smart contract on the Robson test network. So here's the data. It's going to get filled out in this transaction object here. Here's the gas price. Here's the gas limit. And here is the nonce, which is, the transaction count for this smart contract, or sorry, for this account, right? And remember, so basically this is building the transaction object. This is signing the transaction with this Ethereum Ethereum.js TX library. And then this is actually using the Web3 library to broadcast this raw transaction, which is the whole point. This is building a signed raw transaction, and then send signed transaction. So essentially, sign raw transaction and then send signed transaction. And we're going to console log any errors that might happen. And if it's successful, we'll log the transaction hash, and we'll actually go visit this smart contract on the on Etherscan. So let's give this a try. Again, this is just an app.js file that I've created inside this directory, and we can run this file like this, just a node app.js. All right, looks like I have a syntax error here. I forgot a parenthesis, I believe. All right, so it looks like it worked. Let's see. I mean, there could be a couple of issues. There could be, I don't know if the gas limit was high enough. It's not a guarantee that this worked. It broadcast a transaction, but let's actually see if it wrote it. So I'm going to go to Etherscan. Again, I'm going to go to ropsten.etherscan to make sure I'm looking at the Ropsten test network. Paste in the transaction hash, and let's see if it worked. I'm not going to guarantee that it did, but let's find out. All right, so it's pending. You can see that this is contract creation, right? This is the to value. Like I said, we don't actually want to send this to an address. We want to send it to the entire network, and it knows that this is a contract. You can see the input data that we filled out here. You can see the, all this other data that we filled out, right? Here's the transaction hash that we searched by, and boom, look, it was successful. Yeah, we can see this contract was actually created on Ropsten Etherscan, or actually on the Ropsten network, but Etherscan now knows about it. We can click on it, and we can see the contract address. We can see the contract creator. This is the same address that we have been using in this tutorial. You can see all these different values. And yeah, let's copy this smart contract address and actually try to interact with it like we did in the previous tutorials. So I'm going to comment out all this stuff. I don't want to create any more smart contracts. I'll just say this is the contract address. Say const. All right. And what I'm going to do is actually I want to try to interact with this. So I want to get a copy of this smart contract from the blockchain and try to read some data out of it to see if we can pull it back with our connection here. So the other thing that I need is the contract ABI, which is available in Remix, right? We compiled this down, and it shows you this contract ABI here. Let's just copy this again and paste it here. All right. So what I'm going to do is actually take this out, copy this ABI, take it away, and say const contract ABI. Oops. Do that. And then I'll say Dapp token contract is web3.eth.contract. And I'm going to pass in the ABI, contract ABI, contract ABI. I believe that's right, yeah. And then contract address. And yeah, I'll do that. And then let's just console log the contract first. See what happens. Minimize this, clear out some of the noise. Node app.js. All right, we had a little problem here. Web3.eth.contract is not a function. Sorry, this needs to be capitalized. Oh, sorry. I need to do this. Sorry, guys. Okay, so we can see that we at least instantiated this contract correctly with Web3. You can check out the previous videos in this series where I show you, how to do this manually. But here's an example of how just, to create an abstraction of this contract in JavaScript with Web3. And now what we want to do is try to read the name of this contract that was deployed to the network. And we can say, let's say, Dapp token contract, methods, say name, say call. This would be an error, and then this would be the result. You pass it a function. Let's see what happens. Boom, there we go. We got the name of the smart contract back from the Robson test network. We can also check out, let's see, a symbol. And we can see the total supply. All right, we can also see balance of the account that deployed it, which should have all the tokens. Oops. There we go. We can see how many tokens that this account actually has. It has 1 million. All right, guys. So that's that's an example of how you deploy a smart contract manually to the Ethereum blockchain with the Web3 library without having access to like Geth's personal library, or without doing this via the web, or without having to trust the node, without having to run your own node, things like that. This is how you can just sign a transaction with a private key and generate a raw transaction, sign it, and broadcast it to the network. And remember that whenever you're creating a smart contract on the Ethereum blockchain, you're creating, a contract like this, or you're creating a transaction like this, and you're just sending, it's compiled down data in hexadecimal. All right, so I hope that was helpful. Let me know what you thought in the comments down below, and check out the next video in the playlist whenever it comes out. And until then, thanks for watching Dapp University.